Hi there, I'm Hao. This is just another video of me solving random code problem. So given an integer array num where the elements are sorted in ascending order, and we want to convert it into a high balance binary search tree, so the input array is sorted, right? So negative 10, 3, 0, 5, 9. Right, this is our index. Okay. So we know that the middle element, because the array is sorted, right, which means the middle element is always be the root, right, which is like 0 like this, right? And whatever on the left of 0 has to be smaller than 0, right? So negative 10 and negative 3, right? 5 and 9, right? So on and so forth is 5, right? And see, nothing is smaller than 5, right? We just return null, right? Same for here, right? If it's only one element left, then we know that the value is gonna go here, right? It's negative 3. This is 9, right? And we return back up, right? Just like that, right? Which we match our um, tree results here, right? But doing it this way would cost us a lot of time to filter out the element that is smaller than the parent and the element that is greater than the parent, right? We also need some space to store them, right? So understanding this idea, we can do this using some kind of interval, right? So we know that the middle index, right? We have to be able to calculate our middle index. Right? So the middle index can be calculated by mid equal to the low, right? Low less. So this is exactly like the binary search, except like we have to use it to rebuild the tree, right? High minus low, right? And then divided by 2. That will give us the middle index, right? So let's say we start from index 0 and 4, right? 0 and 4. And let me just run it again. See it better. So we start from 0 and 4, right? So 4 minus 0 is 4, right? Divided by 2 is 2. Math the floor of 2 is also 2, right? And low is 0. So 0 plus 2 is 2, right? So our first mid index is 2. So we are having 0 to 4, right? And our mid is 2, right? So what is the value as 2? Which is the 0 here, right? Right in the middle. So we can make note 0 here, right? And as we iterate to the left side, we don't have to find all the elements with the values smaller than 0. We just have to update our upper bound, right? The lower bound stay the same, which is 0 here. And upper bound change from 4 to the middle minus 1, right? Because we already use this index, we cannot use it again. So minus 1, which is 1 here, right? And then using this interval, we can calculate our mid index again, 1 minus 0 divided by 2 equal to 0.5, right? And we can match the floor that it's become 0, right? And low plus, what is low? Low is 0. 0 plus 0 is 0, right? So our mid will be 0. 0 here, which is 2, 0. Let me change the color to make it more obvious. Okay. 0. Okay. All right. So we look at the value at 0. What is the value at 0? Which is negative 10 here, right? So we can continue create a node for negative 10, right? And we keep going left. So what is our bound now? The lower bound always stay the same. And the upper bound will be mid minus 1, right? Because we already used 0, so we cannot use it again, right? So it will be minus 1. Now, because the lower bound is bigger than the upper bound, so that is not valid. So we can just go ahead and return no here, right? So after that, we can, because we finished iterating to the left side, now we look at the right side, right? So when we go to the right side, what is our new interval here? So if we go to the right, then the upper bound stay the same, right? Which is 1. But the lower bound is updated, right? So 0 plus 1, we already use 0, so we cannot use 0 again. So we have to go 0 plus 1, plus 1, comma 1 here, right? And because the low and the high are the same, our mid index will be 1, right? 1. So we look at 1, we have -3, so we make a note for that, right? And we keep going down. So our new interval now is lower bound stay the same. The mid is 1, so minus 1. If we go to the right, upper bound stay the same, right? But the lower bound equal to mid plus 1, right? So 2. Let me also write it down. So right, if we go to the left, right, left, then mid is and then low. We go left and low stay the same, right? Low stay the same, but high equal to mid minus 1. If we go to the right, and the upper bound stay the same, but the lower bound become mid plus 1, right? Because we already use mid, use the mid index, right? Okay. So because now the lower bound is bigger than the upper bound, we return no, right? Same for here, we return no, right? So now we finish with this left subtree. We continue to the right side, right? So when we go to the right, what happened to our interval here? So upper bound is the same. Lower bound is mid plus 1. Mid is 2 plus 1 is 3, right? So what is our mid index? So 4 minus 3 divided by 2 is 0.5, right? Might have floor that becomes 0, right? And low plus low is 3 equal to 3, right? So our mid index will be 3 in this case, 3. Okay. So we look at 3, at 5, okay, 5, and we can go to the left. Our interval become lower bound stay the same, so 3. Upper bound become mid minus 1, so 2, right? So we return no. Okay. If we go to the right side, upper bound is the same, lower bound become 4, 4 and 4, right? So our mid index become also 4. So we look at 4, which is our last value here, which is 9, right? And we are done. It will give us 4 and uh 4 and 3, right? This side give us uh 5 and 4, right? And this will return no, right? And this will match with our resulting tree here. So using this way, we only need the 2 variable to store for the low and the high variable, right? We don't have to store we don't need some array to store the values that is greater than or less than the parent. Okay. And if we look at the constraint right here, we know that the num will be always be at least one element. So that is an edge state that we don't have to worry about. So let's go ahead and try to code this up. Right, so we have to insert into the tree, right, with a lower and upper bound. So we're gonna start from the two end of the array, right? So index 0 and length of length +1. Insert, we can have low and high, low and high. Okay. So if low is greater than high, we return no. Otherwise, we make a new node. We have to calculate our mid index, right? Mid index equal to, or just mid, equal to low plus mat plus floor of high minus low divided by 2, right? And we make a new node. So it is a parent. We put the new node, new tree node, and the value will be the value at this index, right? Mid index. We can set the parent.left equal to insert, right? And we need to, when we go left, the lower bound stay the same, the upper bound will be mid minus 1. When we go right, the lower bound become mid plus 1, but upper bound stay the same, right? And we have to return the parents at the end. So we can do return here too. Okay, so let's give it a try. Okay, accepted. And it worked. Thank you for watching.